What we're going to do now is we're going to figure out how to find out how many protons, electrons, and neutrons are in the atom. So how do we find the parts of the atom? Before we start, we're going to review the structure of the atom. So if you remember, in the center of the atom, we would find the protons. Also in the center of the atom are our neutrons. And let's put a little bit of information next to this diagram so that we remember a little bit about these particles. So our protons have a positive charge, and they're so small they have a mass of 1 atomic mass unit. They're so small we can't even measure them in grams. Our neutrons don't have a charge at all. They're neutral, but they do have a mass of 1 atomic mass unit. Now both these particles together make up the nucleus. So this is the nucleus of our atom. Now spinning around the outside in energy levels are going to be our electrons. Now a real atom is not going to have a dashed line around it. This is just to represent the energy levels. And those energy levels are going to become very important in a couple of lessons. So dash around the outside are our electrons. I've drawn them big there just to make a point, but they're really, really tiny. So here's our electrons. Remember, they have a negative charge, and because they're so tiny, we just say they have a mass of 0. So the 0 atomic mass units. For us at this point, saying that it's 0 is fine. All right, next step. So we need to look at our periodic table. All the information you need to know about your elements at this point are on the periodic table. So you should have a periodic table that looks like this. It's pretty simple. If you don't have one, just look one up on the computer or put one on your phone or whatever. It doesn't matter. On the periodic table is a bunch of information. The first thing up here, this number up here, all right, this is the atomic number. And every element has their own atomic number. The atomic number is determined by the number of protons that are in the nucleus of the atom. So every element has a particular number of protons in the nucleus, and that's what makes the atom what it is. So if I wanted to know what element has 6 protons on the periodic table, I would know that it's carbon. If someone asked you which element has 6 protons, you would say it's carbon. If someone said to you, how many protons does carbon have? You would tell them 6 because it's number 6 on the periodic table. So this is the element symbol. This is the element name. And this is the average atomic mass. Now we're going to do something with this atomic mass. The atomic mass is usually in a decimal because what scientists have done is they've taken as much carbon as they can, they've found the mass of it all, and then they've averaged it out. It's like taking everybody in your class, weighing everybody, adding it all up and dividing it by the number of people in your class, and you're going to get an average mass of your class. But each individual person is going to have their own particular mass. So this is the average atomic mass. So when we're talking about our elements, what we're going to do is we're going to round it. So when we're using the mass, we're going to be rounding it. All right, so first thing is, an atom just on its own is going to be neutral. So there's not going to be a charge on an atom. So if we know that an atom is going to be neutral, we know we have to have equal number of positive protons with negative electrons so that they balance each other out and come out to be neutral. So since an atom is neutral, that means that the number of protons which are positive, right, remember these guys are positive, has to be equal to the number of electrons because those guys are negative. So therefore, if we want to just make a little rule here, we could say the number of protons in a neutral atom is equal to the number of electrons. So if you want to find your number of protons, we're going to look at the atomic number. That's up here. We're going to look at the atomic number. So for carbon, the number of protons is going to be 6 because its atomic number is 6. And then if we want to find out the number of electrons, we can do the same. Since we know the number of electrons has to be equal to the number of protons in a neutral atom, well, we know if we have 6 positive protons, we must have 6 negative electrons. So we're going to also look at the atomic number. Right? So pretty easy stuff there. But how do we figure out the number of electrons? If we go back, we know that most of the mass of the atom comes from the nucleus with the protons and the neutrons in there, and they each weigh 1. So what we can do is we can use this information to take the mass that we've rounded minus the number of protons, and that will give us our number of neutrons. All right, so how do we find the number of neutrons? The number of neutrons is equal to the atomic mass rounded minus the atomic number. All right, and under here, just to remind ourselves, we're going to take that atomic mass and we're going to round it. So let's go back and let's find our number of protons, our number of electrons, and our number of neutrons using this information from here. So our number of protons we know is equal to the atomic number. So since the atomic number is 6, for carbon our number of protons is 6. For our next thing, our electrons, we know our number of electrons is going to be equal to our number of protons because we have to have equal negative particles to our positive particles, so we know our number is going to be 6. And lastly, with our rule, we know that our number of neutrons is going to be the mass that's been rounded minus the atomic number. So in this particular case, we're going to round this to 12. So our number of neutrons is going to be 12, that's our atomic mass, minus 6, which is our atomic number, and that answer is going to give us 6. Now, not always are the number of protons, electrons, and neutrons going to be equal. For the first 20, sometimes that happens. It doesn't happen all the time, but it's not a rule. They're not always the same number all the way along. So let's take a look now and do an example for phosphorus. So first thing we're going to do is we're going to look at phosphorus, and we see the atomic mass here. All right, so it's 30.974. So what we're going to do is we're going to round this to the closest whole number. So we're going to round this up to 31. Alrighty, now we're going to take a look here, and we're going to say our number of protons. Our number of protons is equal to our atomic number. So we know that's going to be 15. We know our number of electrons has to be equal to our number of protons if our atom is neutral, so that's going to be 15. And lastly, we're going to do our number of neutrons, which is going to be our atomic mass minus our atomic number. So in this particular case, it's going to be 31 minus 15. And that's going to give us 16. So we're going to do our atomic mass minus our atomic number. Let's take a look at iron now. So for iron, we're going to take a look at our atomic mass here, right, which is 55.845. We're going to round it to the closest whole number. So in this particular case, we're going to round it to 56. Alrighty, so we're going to look at our number of protons. Our number of protons is equal to the atomic number, so that's 26. Our atom is neutral, so our number of electrons, which are negative, are going to be equal to the number of protons, which are positive, so that's going to be 26. And our number of neutrons, we're going to take our mass minus our atomic number, and that's going to give us our number of neutrons. So we're going to do 56 minus 26, all All right, and that's going to give us 30. So in this particular case, our number of neutrons is 30. Our last example, we're going to do gold. So for gold here, look at our atomic mass here, 196.967. Let's round that up to 197. So our number of protons equal to the atomic number is 79. Our number of electrons, which are negative, are going to be equal to our positively charged protons in our neutral atom. That's going to be 79 as well. And then our number of neutrons, we're going to take our atomic mass minus our atomic number, and that's going to give us our number. So we're going to do 197 minus 79, right, which is going to give us 118. So we have 118 neutrons in there. So now you give it a try with the worksheet. We'll talk next time.